That question has been already answered. Ingenuity answered that question quite well because it has exceeded any expectation so far.
This is Have We Gone to Mars Yet? A podcast about all the things that need to be sorted before we can put a person on the surface of Mars. And today, we dig into something really fascinating. Mining in space.
And mining on Earth. Because a lot of the technology we will need on our future mining missions to Mars are already in use, deep in the mountains of northern Sweden.
We went to Kiruna and met up with Nikos Petropoulos, research engineer at LKAB, to talk about robots and drones and how they can be used to explore and excavate around the universe. My name is Susanna Levenhaupt.
My name is Nikos Petropoulos.
And this is Have We Gone to Mars Yet?
You've probably seen that cute, dog-looking robot from Boston Dynamics on clips circulating on the internet. It's called Spot, and it's not just cute and fun to look at, but also incredibly useful.
These robots can be programmed to perform different tasks in areas that are difficult for humans to reach. No wonder the mining company LKAB decided to offer Spot to come work for them.
So a while back, Nikos Petropoulos got a new favorite colleague. But Nikos, tell us how it all started.
2 years ago, we decided to test the, at that time, newly come out in the market quadruple robot by Boston Dynamics, so-called Spot. Since that time, LKAB has bought 3 of these robots, which 2 of them are working in the mine right now, and 1 robot is used by the researchers for further development, to customize it so it fits exactly our needs and tailor the missions that we design for the mines.
What is it they do?
Inspection missions, where either they are doing patrolling, where they investigate areas of the mine, either that nobody is allowed to access due to safety reasons, or regular inspections to check the rock mass stability, the quality of the air, if everything is in place, so to say. Because we are talking about an underground operation, and there are way too many variables and things that can go wrong.
The investigation, how does it do it?
2 ways. Either the operator will remotely control the robot and go to the area in question and take measurements, or the robot has been programmed in advance to go to that area, take measurements, and go back home, so-called, where it will upload the data on the server for the engineers and technicians to evaluate a situation. It's a RGB video. There might be a thermal camera on it, where we check differences in temperatures and so on. We have a LiDAR scanner. LiDAR is a device that will give us a scan of an area by means of a point cloud. And also we have installed gas sensors on the robot, where we can make a heat map, so-called, of the area to investigate if we have gas pockets along its path.
So you always send a robot in first before you send people?
In areas that are relatively unsafe to access, yes.
You said you scan. Is it like... How does it work? Is it like 3D scanning of the tunnel, how it looks?
Exactly. Imagine that is a rotating beam of laser that continuously measures distance between the robot and the wall. And it gathers all these points. And based on all these points, it creates so-called point cloud. Imagine that building here or that room here, and we have a scanner. We will not see the surface, but we will see a sum of dots all around us, which cumulatively will give us the topography, let's say, of the room. If Spot stops and the robot understands that, okay, I cannot go further in. It can deploy a drone, where the drone will have its own autonomy to further explore an area and collect data and send back to Spot. That in that case, Spot is used as a hub, and Spot uploads the data to the server. How the drone to come back and land, that's a very tricky part.
Okay, but does it work?
It works.
It works. Yeah. Okay.
Yes,
so it's not that hard.
It's not, yeah.
I would say it is not. It is possible. Hard or not, that's a different story. But it is possible. And this technology can be further used on extraterrestrial objects, asteroids, Mars, and so on.
What are the differences between building a robot for mining on Earth and building a robot for mining on an asteroid or on another planet?
Well, I will say there is not so much difference. As long as a robot is not oxygen dependent, where our robots are not, because they're battery driven, then the problems are similar as we have on Earth, where to reach 100% autonomy, that's the biggest challenge. Because here on Earth, yes, if the robot fails, we can somehow recover it. Up on Mars or another asteroid, we have lost the system. The system will not be easily, I would say, recoverable. If it's an asteroid, most likely we have lost it. But we are working towards this process to make the mines here on Earth much, much safer. That means less people in the production. And this technology will be used to implement it on a different planet or asteroid.
For how long can it work on its own? How far can it go?
Spot, with its current battery, it can run for 90 minutes, 1 hour and 30 minutes. And with its specs velocity, it can walk maximum 4 kilometers. When we say 4 kilometers, these are ideal numbers. And technically speaking, you can have multiple charging stations along its path. Then Spot can walk for 4 kilometers or 3, let's say, to be on the safe side. Spot can go charge its battery and continue further on. The same principle can be applied on Mars because, as I said, the only restriction there is the oxygen, nothing else. Spot and the robots, based on their onboard vision systems, and I would say see, in quotes of course, and understand its surrounding environment. And then it can somehow protect itself with all the avoidance, collision avoidance systems and all these AI algorithms that are running on board.
You can both use Spot to go around in the mines and scan it. And also you talked about that you can use drones. So we're talking on Mars, maybe almost like in Prometheus, where you have like flying drones in the tunnels.
Actually, that's a reality today. In our mines, in LKAB mines, we are using drones to scan areas. We are using drones to investigate areas. Then we just combine two existing technologies. Of course, drone is further more developed compared to walking robots. But at some point, these two technologies will merge and will go together. Then, yes, we can implement such technologies there, and it will look like a Prometheus concept.
How big of a system could you scan?
Today, with the so-called LiDAR systems, the radius is 100 meters. That means the length that we can measure is 100 meters around the scanner, in that case. Then we have quite good potential to scan almost any cavity relatively, in relative size, of course, cavity that we can have. It's the same as in the mines today.
Because we have a flying helicopter on Mars, so exactly. Would it work there?
I think it's that question has been already answered. Ingenuity answered that question quite well because it has exceeded any expectation so far with its flying time, flying distance, and also the number of missions. But yeah, of course, that system will work. Underground, we might need to pump some air in the mine to have some circulation, because we know that Mars has very thin atmosphere. That means our drones have to be slightly more powerful to work there, because the RPM, the rotations of the propellers, needs to be much, much higher compared to normal drones that we have here on Earth.
Will we use these drones and robots for exploration missions only, or will they do other things as well?
The thing is, we cannot have a universal robot, a robot that will do everything. Then we will have a specific, we will design robots that are for inspection, exploration. We will design robotic systems that are for excavations, for digging, and so on. Even today, all the semi-autonomous loaders, trucks, and so on are specifically designed for loading, for transportation purposes, for all these things. We cannot have one for everything.
But we do have today robots that can, or machines that can 3D print houses. Is it possible, you think, to send an autonomous system in the future to go there? Not maybe one robot, but different robots together. To one that goes do the scanning, and one that do all the digging, and one that do the building, without people being present.
Yes, that is very likely scenario. We are not there yet, but yes, that's what I said before. You have certain robots doing certain tasks. Put them in a process, in a chain, and then the output from one robot will be the input for the next process. And then the robot that is for excavation or checking the quality of regolith or checking the quality of the bedrock, excavating the rock, the material, break it into manageable size particles, and then provide that material to the next robot that will make bricks or make the raw material for building something. Then the next robot will go there for supporting or installing infrastructures and so on. Then it's a series of process. Something similar can happen also here on Earth, where we have the machine that can go a fully autonomous mining operation. We have a machine that will go and drill. Then when the machine is done with drilling, it will give data about the quality of drilling to a charging machine. Then a robotic charging machine can go there, charge, blast the tunnel, so to say. So we go ahead. Then the next machine will come, take out the material, support the area, and then you start all over again. Then yes, this is possible. This is one of the visions for mining on Earth, but yeah, it's applicable on asteroid mining and mining on Mars.
So will LKAB be present on Mars doing all these things?
I hope so. I hope so.
We've talked a lot about Mars now and Earth. But if we move on to smaller places like asteroids, and then ask the question, why should we build a mine on an asteroid? What's the purpose?
On a relatively big extraterrestrial object like Mars, an asteroid is much, much smaller. And asteroids can be have much higher content of different types of minerals, iron, most of them are iron, and so on. Then we have our mineralization, our deposit, so to say, in a more concentrated area. Also, asteroids have rare earth elements, REs, which even the name define these elements are rare on Earth, but are in large amounts on asteroids.
But even when the rockets and the spaceships become better, and we go to an asteroid that have very rare minerals that we need, will it be worth it to take them down to Earth?
Yes and no. Because will you have atmospheric entry and have the material in a spaceship? or you will send the material down to Earth like a comet. Then depends on what quantities, or it will be easier to develop the product up in space and deliver the product down to Earth. When you deliver raw material, large part of it is waste material. Why shall we pay for that? Why shall we invest for something that we will dump it somewhere because it's no use?
So we will not only have mines in space, we will also have factories that make chips and...
Potentially, yes.
That interplanetary economy we've been talking about isn't so far away now. Mines and factories in space. Sci-fi as it may seem, it might be closer than you think.
I'm looking forward to that shift. Instead of draining Earth completely to feed our needs, we can move those operations to areas where nobody is affected by the downsides.
And I'm looking forward to when a crew of spots is sent to Mars to explore and build and terraform and prepare our red neighbor for human visitors. But now we need to wrap it up for today. My name is Nikos Petropoulos.
My name is Susanna Levenhaupt.
The music we play is composed by Armin Pendek.
Have We Gone to Mars Yet is produced at Beppo by Rundfunk Media in collaboration with Rymdkapital. Read more about them and how you can get yourself involved at havewegonetomarsyet.com.
Hallå? Programmet gjordes av Rundfunk Media.